I'm Carl Birkeland from the Forest Service National Avalanche Center, and we are going to do an extended column test. Now, for an avalanche to occur, we need both fracture initiation, and then we also need that fracture to propagate. So we need initiation and propagation. And with the extended column test, we're looking not only how a fracture initiates, but also how that fracture propagates across this wider column. And that gives us some sort of indication of how likely fracture propagation is within the area that you're testing. There's some advantages of using an extended column test over some of the other available tests. The compression test is a good test to show you how likely a small area is for a fracture to initiate, but it doesn't tell you too much about fracture propagation. When we start looking at shear quality associated with our compression test, then that starts to give us a little bit more of an indication of fracture propagation. Now, when you do a Roosh block test, that test again is more looking at fracture initiation unless you start looking at the block and the way the block releases. If the whole block releases, that's giving us a pretty good indication that the fractures are propagating fairly well, or if most of the block releases, but just if an edge of the block releases, it doesn't. But again, the Roosh block isn't specifically designed to try and look at this fracture propagation potential like the extended column test is, and also like another test in development in Canada, the propagation saw test. Now, to do an extended column test, we need to first dig the snow pit deep enough so we're down to the weak layer of interest. And in this particular snowpack, we're interested in this faceted depth hoar layer down near the bottom. Then we need to isolate a column that's 90 centimeters wide and 30 centimeters into the hill. So 90 centimeters by 30 centimeters. And that's about 3 feet by 1 foot. So I'm going to measure that out here. "90 centimeters. Oh. 30. And by far the easiest way to isolate your block of snow is to use a couple of probes. So we put a probe in at each corner. You can isolate your block with a saw, but that's a little bit more difficult. And then all you need to do is just go find a piece of rope, small rope, and tie some knots in it. And that'll work for a lot of snowpacks. Some snowpacks, if you have a lot of hard snow, you could actually tie little washers on here, little piece of metal. You can also use thinner rope, and that'll cut through harder snow more easily. So go ahead and put the rope around the probes like this. And now we're just going to saw down, and you have to make sure you saw as deep as the weak layer, at least as deep as the weak layer. If you have ice crust or something, it might take a little bit more, patience. You want to make sure that block is completely isolated on all 4 sides. When you're sure that's cut all the way down through, then you just pull the string through on one side, and you've got an isolated block. Now, I like to then take a snow saw and make sure my sides are nice and straight. So you can go ahead and isolate those. By isolating the side, we make sure that that block isn't going to bind when it's sliding out. So we don't want it binding at all on either edge. Now we're ready to do the test. And what we do is we load the test the same as a compression test. So we're going to put our shovel, and we load it from one side of the block. So we'll put our shovel over here on one side of the block, and we'll load it with 10 taps from our wrist, 10 taps from our elbow, and then 10 taps from our shoulder. And we're looking at not only whether or not this fracture initiates down in our weak layer, but also whether or not that propagates across the entire block. That would be an ECTP, or an extended column test that propagates. You can see that when that fracture first initiated across the bottom of the block, it then propagated across the entire block, and it propagated down on this thick layer of depth hoar near the ground. In terms of interpreting the test, when we get conditions like this where the fracture initiates and also then propagates across the column in the same loading step, that's telling us that the conditions that we have right now are conducive to fracture propagation. On the other hand, if the test result, it doesn't propagate all the way across, sometimes it'll propagate part way across and then break through the block, or you just don't get it to propagate across on that same or next loading step, then those are conditions under which fractures are less conducive to propagating over large distances. So in this particular case, the test is showing that fractures are more likely to propagate given snowpack conditions similar to what we're finding in this pit here.